Good afternoon. My name is Katie Strailey. I'm a postdoctoral research associate at the Illinois River Biological Station, where I'm working on novel ways of removing invasive fish species like carp while promoting the passage of native fish species over barriers. This project is something that we've been working on for several years, and I'm excited to share with you where we've been, where we are, and where we're going, along with some of the things we've learned along the way. So first, dams act as a major barrier for native migratory fish. Now, fish may sometimes be able to move up and downstream if a dam has a lock chamber, but not all dams have locks, and these aren't designed specifically for fish. So it may not be easy to use them, and not all fish species use them. So dams make it difficult for fish to go where they need to go, when they need to go. But there's also a bit of a silver lining to them because while they block native fish, they also block invasive fish. So Illinois is now host to 5 species of non-native carp. 4 of these, bighead, black, grass, and silver carp, are commonly referred to as the invasive carp species. And it's thought that dams have sort of helped to slow the spread of these fish and delay their invasion in the Illinois River system, as well as in other river systems throughout the Midwest. So that puts us in a little bit of a pickle. Native fish need to be able to move, but we don't really want invasive fish species to be able to move freely. So ultimately, a need exists for us to be able to selectively pass native fish over barriers while inhibiting the movement of, or perhaps even removing, invasive fishes like carp. So, how do we address this? The Illinois River Biological Station, Illinois Department of Natural Resources, the Nature Conservancy, and Whooshh Innovations came together to test an innovative new fishway with the eventual goal for this fishway to provide a way for native fish species to move over barriers while preventing the movement of invasive fish species like carp or even removing them from the system altogether. So obviously we have some scientific objectives, things that we want to learn from using this fishway. So first, very important, figure out if fish will actually use the fishway. If fish won't use it, doesn't really matter. And then second, to identify factors that may motivate and attract invasive carp to use the fishway. We are specifically very interested in removing carp. Now, this is also a very engineering focused project with a lot of technology involved. So we also have technical objectives. So evaluate the feasibility of operation and its use by fish, and identify opportunities for additions to the design and improvements on the design. And today, I'm really going to be focusing a lot on this technical side, what we've learned throughout the process, how we've made things better, and how we're planning to continue making things better moving forward. So, if I'm talking about dams on rivers, then why am I here talking to you today at the Emiquon Science Symposium? Well, that is because our testing site is on the Emiquon Preserve. So you can see here in this picture on the left, I have it circled. We have been operating this fishway next to the water control structure at Emiquon in a side channel that leads to the Illinois River. And I just want to stress that while this is on the Emiquon Preserve, this is on Nature Conservancy property, we are connected not to the preserve, we are connected with the river. And so fish are able to freely move into this side channel from the river to potentially use the fishway. Now, you might think, why are we starting at Emiquon? Why not a dam? Well, you want to really make sure that what you're doing works before you take it to a dam. You can probably imagine operators aren't really going to be interested in hosting you if you can't promise them you're going to have a result. And we also know that if we're getting fish coming through this fishway here, when they're not actively trying to move upstream through a dam, that we really know that we are attracting them. They aren't just happenstance encountering this fishway. So in fall 2020 and spring of 2021, we operated directly next to the water control structure at Emiquon. And so the fishway was composed of three basic parts. This ramp is called the steeppass. This component is called the flow box, where water actually enters to provide water to the rest of the system. And then at the back is the false weir. Water was being provided directly from Emiquon, so we were not using water from the Illinois River. And during this time, we had two cameras installed over the fishway so that we could record video of any fish moving through. So if a fish were to move through the fishway, they would start from the river, swim up the steep pass, into the flow box, through the false weir, and then get deposited into a holding chamber within the water control structure so that we could do some ground truthing to see what species of fish we were catching, as well as to do measurements. Excitingly, the fishway was used in both 2020 and 2021, and we actually had quite an abundance of fish, catching nearly 2,000 fish in this time from quite a range of different types of fish. And very excitedly, we caught several of our target species, including 17 grass carp, one silver carp, and a common carp. So this taught us our first lesson, one that was very exciting, very happy, which was that a variety of fish with a variety of swimming abilities are capable of using the fishway. Now, some of these fish species may be considered to be pretty decent swimmers. Silver carp, famous for their crazy jumps, have pretty good swimming performance, but a lot of these fish are not necessarily fish that you would associate with high velocity areas with a good swimming ability, but that didn't stop them. They were still able to use the fishway. So it turned out to be a good thing that we were catching fish physically, because when we had our camera set up, less than half of the fish that actually used the fishway showed up on video. And that's probably because a lot of the time, video looked like this image on the right. You really couldn't see much. Even at the best of times, if you know a fish is there, you're standing directly over it, looking down on it, you often cannot see a fish moving through the fishway. And so in 2021, we switched to a different system because we learned that standard cameras just really weren't going to suffice. It wasn't possible to clearly see everything that was moving through the fishway. So we installed an AI-powered scanner that you can see at the bottom right corner of the right-hand image here. And so this scanner takes 18 pictures per second of any fish that comes through the steep pass. And it also has an algorithm that allows it to estimate the size of fish that are moving through the system. Now, unfortunately, the fishway was only able to run for 32 days because of river stage. So that was only 3 in 2020 and 29 in 2021. And that was because we had a situation in which at times we would have very low river stage and at times we would have very high river stage. So in this top picture where the red line is shown, that's showing the optimal stage for operation. And so below this, it could be difficult for fish to even reach the base of the fishway to use it. In 2021, we had issues with having low stage, but we also had issues with having extremely high stage, where it got to a point where the electronic components, such as the scanner, were actually threatened because water was getting too close, and we had to stop operation to remove the scanner to get it away from the flow. So this brings us to an extremely important lesson that we've learned, probably one of the most important, something that is still affecting us, which is that rivers are fickle, to sort of humanize a river. We have locks and dams that are in many ways meant to help regulate the river, but ultimately this is still a wild system, and it can be really difficult to predict what may happen at a certain time of year. And so So we had to figure out what we could do to deal with this dynamic, always changing river that had the potential to have very fluctuating river stages. So we went back to the drawing board and thought about design options, things that could be done to free us from the wild fluctuations that the river sometimes offered us. And so one of the biggest changes was that we moved from having the fishway just mounted directly on the river bottom and instead moved to a floating barge mounted design. So all fishway components are now mounted on a barge. This allows it to move up and down with the river, protecting any technological components on board if the river is high, but also still allowing fish to potentially get to it if water is low. We added an adjustable steep pass where the angle can be changed depending on the current need of the project. Previously, it took a crane to move. Now it can be done with a couple people and a couple impact drivers. And we also added a pump. This would allow us to be free from using water at Emiquon, allow us to move to other places, and the rotating design allows us to protect the pump while moving the system or in case of extremely low water. So the current iteration of the fishway is now in its home in the Emiquon side channel, and it's more adjustable than ever. And perhaps one of my favorite things about it. So the fishway is now completely mobile, and we're capable of moving it even with our own boats that we have for just regular field work at IRBS. And so this offers us so many new opportunities to be able to move it to new places in the future and try out new things without needing to fully disassemble it, which is really exciting. And so I imagine you're probably very excited to hear how this newest iteration has gone and hear what we've been catching. So unfortunately, no fish volitionally used the fishway in 2023. We have confirmed that fish should be able to. We did testing with fish that we captured via electrofishing and sent through portions of the fishway. You can see here a silver carp. And we have demonstrated that fish physically can move through. They, for some reason, just haven't. So this has brought us to another important lesson. This lesson is that the timing needs to be right. So we began operating in mid-September and ceased in mid-November. And during this time, the main attractant we were offering for fish was the flow coming through the fishway. Now, we think that flow has the potential to be a strong motivator and attractant for fish, especially for big-headed carps, because these fish species are broadcast spawners that will time their spawning events with flood pulses when lots of water is coming into a system and using that to help disperse eggs. And so we think that during spawning season, flow could potentially be a great motivator to encourage fish to use the fishway. But we were operating in mid-September. It was not warm for very long after we started operating. And realistically, while there may have been some spawning occurring in the system, there probably wasn't much at that point, and it just wasn't going to be much of an attractant. We also now have a key difference from our operations in 2020 and 2021, which is that we are using water from the Illinois River rather than from Emiquon. Now, it's well known that Emiquon continues to have quite a healthy population of zooplankton and phytoplankton with greater biodiversity and abundance than the mainstem Illinois River. There may likely be other things going on in Emiquon, but essentially water that is coming from the river has a different signature than water that came from Emiquon. And so it's likely that there were things that fish were sensing in that water coming from Emiquon that served as an attractant for them. And so this illustrates for us that Flow likely alone is not going to be enough to attract fish, especially carp. We don't exactly know what the difference was, what specifically it was that motivated fish to be attracted to that Emiquon water, but there was something in it. And so what we've learned in 2023 has really informed us and given us great ideas for what we're going to be doing moving forward in 2024. So this year we're going to be testing additional attractants. We're going to be using an algae-based bait. We're currently coordinating with the U.S. Geological Survey on that. And this is a product that they've used and tested to some success. So we're going to be utilizing that to lure fish. We're also going to be covering the steeppass. As you can see, it is quite bright, it is quite shiny, and so all of that light can potentially be a deterrent for fish and make them not really want to utilize the steeppass. And so these are just two of the things that we're really excited to be trying this year to improve our results. Moving forward in the future, further on down the road, once we have gotten to a point where we are successfully and consistently capturing our target species, our plan is to add a fish sorting and moving system that gets added on to the back of the scanner. So this is a highly modular system that can be adjusted and used. By capturing fish and sending them through our scanner and having pictures taken of them, we'll be able to train the artificial intelligence to recognize what fish is a carp and what fish is not a carp, which will then allow them to be sorted and diverted different ways. And then at this point, we hope that we're going to be able to move forward with testing at an actual dam. And with that, I just want to acknowledge all of the many people that have played a role in this project so far. I came on board in 2022, and so this baby was already going and growing before me. And so special thanks to Phelps and Maxson, who previously coordinated this, all of our technicians at IRBS, staff at Whooshh, the Nature Conservancy, all of the various people that have helped us to build this and learn how to run it, and IDNR, of course, for funding us. And with that, I'm happy to take any questions. If you have any questions that pop up later, you can contact either me at this email or Jim Lamer, our director, at this email. Thank you.